Plenum-rated ballasts are essential in spaces used for return air, such as the ceiling space above a drop ceiling. The primary reason is that ballasts can release hazardous fumes during a fire. These fumes can then be drawn into the return air system, posing a risk of distribution throughout the entire building. Therefore, installing ballasts inside a box is a straightforward and effective method to comply with safety regulations. The box itself can be constructed from any non-combustible material, for instance, metal or plastic. The ballast should be securely mounted within the box, and the box should be properly sealed to prevent any leakage of fumes. Firstly, select a box that is appropriately sized to accommodate the ballast and all necessary wiring. This will ensure there's enough space for proper installation and heat dissipation. Secondly, securely mount the ballast inside the box using screws or bolts. This will prevent the ballast from moving around and potentially causing damage or electrical hazards. Thirdly, seal the box around its edges using caulk or weather stripping. This will prevent any fumes from escaping in the event of a ballast malfunction or fire. Fourthly, ensure that the box is adequately ventilated to prevent overheating. Overheating can reduce the lifespan of the ballast and potentially create a fire hazard. By following these steps, you can safely and easily install ballasts inside a box, meeting the requirements of your local electrical code and ensuring the safety of the building's occupants. The National Electrical Code, or NEC, provides guidelines for electrical installations, and local codes often reference or adopt the NEC. It's important to consult your local electrical code for specific requirements in your area. Proper ventilation is critical. While sealing the box is important to contain fumes, you also need to ensure adequate ventilation to prevent heat buildup. This might involve using a box with ventilation openings or providing additional ventilation in the area where the box is installed. Check with the ballast manufacturer's specifications for recommended operating temperatures and ventilation requirements. Non-combustible materials are crucial for the box's construction. Metal boxes are a common choice because they are non-combustible and provide good protection. Plastic boxes that are specifically listed as fire-resistant or non-combustible can also be used. Ensure that the box you select is rated for the intended use and meets the requirements of your local code. When sealing the box, use caulk or weather stripping that is rated for high-temperature applications. This will ensure that the seal remains effective even if the ballast gets hot. Apply the sealant carefully to all edges of the box to create a complete seal. The location of the box is important. Ensure that the box is installed in a location that is easily accessible for inspection and maintenance. It should also be protected from physical damage. The box should be securely mounted to a solid surface to prevent it from falling. Consider the ambient temperature of the installation location. Ballasts are sensitive to temperature, and operating them outside of the specified temperature range can reduce their lifespan or cause them to fail prematurely. If the installation location is subject to extreme temperatures, you may need to use a ballast that is specifically rated for those conditions. Wiring connections within the box must be made properly and securely. Use appropriate wire connectors and ensure that all connections are tight. Follow the manufacturer's instructions for wiring the ballast. Grounding is essential for electrical safety. Ensure that the box and the ballast are properly grounded according to the requirements of your local electrical code. This will help to prevent electric shock in the event of a fault. Regularly inspect the ballasts and the boxes for any signs of damage or deterioration. Replace any damaged or worn components promptly. This will help to ensure the continued safe and reliable operation of the lighting system. Keep a record of all ballasts installed, including their location, date of installation, and any maintenance performed. This will help you to track the performance of the lighting system and identify any potential problems. Consider using energy-efficient ballasts. Energy-efficient ballasts can save you money on your electricity bill and reduce your environmental impact. When replacing ballasts, consider upgrading to energy-efficient models. Proper disposal of old ballasts is important. Ballasts may contain hazardous materials, so it's important to dispose of them properly. Contact your local waste management authority for information on how to dispose of old ballasts in your area. consider consulting with a qualified electrician. If you're not comfortable working with electricity, it's best to consult with a qualified electrician. Our electrician can ensure that the ballasts are installed safely and correctly, and that the installation meets all applicable codes and regulations. Always disconnect power before working on any electrical equipment. This will help to prevent electric shock. Use appropriate safety equipment, such as gloves and eye protection, when working with electricity. Never work on electrical equipment when you are wet or standing in water. Be aware of the potential hazards of working with electricity and take steps to protect yourself. If you're unsure about anything, ask a qualified electrician for help. Remember that electrical work can be dangerous, so it's important to take precautions. Staying informed about electrical safety practices is crucial for anyone working with electrical systems. This includes understanding the National Electrical Code, or NEC, and any local amendments. The NEC provides comprehensive guidelines for electrical installations, covering everything from wiring methods to grounding requirements. Local codes may have additional requirements that are specific to your area. It's important to stay up to date on the latest codes and regulations to ensure that your electrical work is safe and compliant. Consider attending training courses or workshops on electrical safety. These courses can provide you with the knowledge and skills you need to work safely with electricity. They can also help you to stay up to date on the latest codes and regulations. There are many resources available online that can help you to learn more about electrical safety. The National Fire Protection Association, or NFPA, offers a variety of resources, including articles, videos, and training courses. The Occupational Safety and Health Administration, or OSHA, also provides information on electrical safety in the workplace. In addition to the specific requirements for ballasts and return air plenums, there are many other electrical safety considerations that you should be aware of. These include proper grounding, overcurrent protection, and the use of appropriate wiring methods. It's important to understand these concepts and to follow all applicable codes and regulations to ensure the safety of your electrical installations. When working with electricity, it's always better to be safe than sorry. If you're ever unsure about something, it's best to consult with a qualified electrician. They can provide you with the guidance and expertise you need to work safely and effectively. Remember that electrical safety is everyone's responsibility. By taking the necessary precautions, you can help to prevent accidents and injuries. The electrical codes evolve over time to incorporate new technologies and address emerging safety concerns. Staying informed about these changes is essential for ensuring that your electrical work is always up to code. Many jurisdictions offer continuing education courses for electricians and other electrical professionals. These courses can help you to stay up to date on the latest code changes and best practices. In addition to formal training, it's also important to stay informed about industry news and developments. Trade publications, online forums, and professional organizations can provide valuable insights into the latest trends and challenges in the electrical industry. Consider subscribing to relevant publications and participating in online discussions to stay connected with your peers and learn from their experiences. The NEC is updated every 3 years, so it's important to review the latest edition to ensure that you are following the most current requirements. The NEC is a complex document, so it's often helpful to attend a training course or consult with a qualified electrician to understand the changes and how they apply to your work. Local amendments to the NEC can also vary from jurisdiction to jurisdiction, so it's important to check with your local authorities to determine the specific requirements in your area. Staying informed about these amendments can help you to avoid costly mistakes and ensure that your electrical installations are compliant with all applicable codes and regulations. Proper labeling of electrical equipment is essential for safety and maintenance. All electrical panels, circuits, and equipment should be clearly labeled to identify their purpose and voltage. This can help to prevent accidental contact with energized parts and facilitate troubleshooting and repairs. Labels should be durable and weather-resistant to ensure that they remain legible over time. They should also be easy to understand, using clear and concise language. Consider using color-coded labels to further enhance clarity and organization. Regularly inspect labels to ensure that they are in good condition and that they accurately reflect the current configuration of the electrical system. Replace any damaged or missing labels promptly. In addition to labeling electrical equipment, it's also important to provide adequate signage to warn of potential hazards. This includes warning signs for high voltage areas, arc flash hazards, and other potential dangers. Warning signs should be prominently displayed and easily visible. They should also be written in multiple languages if necessary to ensure that they are understood by everyone who may enter the area. The NEC contains specific requirements for labeling and signage, so it's important to consult the code to ensure that you are in compliance. Proper grounding is one of the most important aspects of electrical safety. A properly grounded electrical system provides a low impedance path for fault current to flow back to the source, which helps to trip circuit breakers and prevent electric shock. Grounding also helps to reduce the buildup of static electricity, which can damage sensitive electronic equipment. The NEC contains detailed requirements for grounding electrical systems, including the size and type of grounding conductors, the methods for connecting grounding electrodes, and the requirements for bonding metal enclosures. It's important to follow these requirements carefully to ensure that the electrical system is properly grounded and that it provides adequate protection against electrical hazards. Regularly inspect the grounding system to ensure that all connections are tight and that there are no signs of corrosion or damage. Test the grounding system periodically to verify that it is functioning properly. If you find any problems with the grounding system, correct them promptly. Arc flash is a dangerous electrical hazard that can occur when there is a fault in an electrical system. An arc flash can produce extremely high temperatures, intense light, and a pressure wave that can cause serious injury or death. Arc flash hazards are present in many electrical systems, but they are particularly dangerous in systems that operate at high voltages or currents. The NEC contains requirements for arc flash hazard assessments and for the use of personal protective equipment, or PPE, to protect workers from arc flash hazards. An arc flash hazard assessment should be conducted by a qualified person to determine the potential arc flash hazards in an electrical system. The assessment should identify the arc flash boundary, the incident energy, and the required PPE. Workers who may be exposed to arc flash hazards should be trained on the hazards and on the proper use of PPE. PPE for arc flash protection includes flame-resistant clothing, gloves, face shields, and helmets. The level of protection required depends on the potential incident energy. Always wear appropriate PPE when working on or near energized electrical equipment. Regularly inspect PPE to ensure that it is in good condition and that it provides adequate protection. Do not use PPE that is damaged or worn. De-energizing electrical equipment before working on it is the best way to prevent arc flash injuries. However, de-energizing equipment is not always possible or practical. In these cases, it's important to follow safe work practices and to use appropriate PPE to minimize the risk of injury. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from damage caused by excessive current. Overcurrent can be caused by short circuits, overloads, or ground faults. When an overcurrent occurs, the overcurrent protection device will trip or blow, interrupting the flow of current and preventing damage to the circuit. The NEC contains requirements for the selection and installation of overcurrent protection devices. The size of the overcurrent protection device should be matched to the ampacity of the circuit conductors. The overcurrent protection device should also be properly rated for the voltage and interrupting capacity of the circuit. Regularly inspect overcurrent protection devices to ensure that they are in good condition and that they are functioning properly. Test circuit breakers periodically to verify that they trip when subjected to an overcurrent. Replace any damaged or defective overcurrent protection devices promptly. Using the correct wiring methods is essential for electrical safety. The NEC specifies the types of wiring methods that are permitted for various applications. Wiring methods include conduit, cable, and wire. Conduit is a rigid or flexible tube that is used to protect wires from damage. Cable is a factory assembly of two or more insulated conductors. Wire is a single insulated conductor. The NEC specifies the types of conductors that are permitted for various applications. Conductors are made of copper or aluminum. The size of the conductors should be matched to the ampacity of the circuit. The NEC also specifies the requirements for installing wiring. Wiring should be properly supported and secured. Wiring should not be subjected to excessive tension or stress. Wiring should be protected from physical damage. Regularly inspect wiring to ensure that it is in good condition and that it is properly installed. Replace any damaged or deteriorated wiring promptly. Always consult with a qualified electrician if you have any questions about wiring methods or installation requirements. Qualified electricians have the knowledge and experience to ensure that electrical work is performed safely and in accordance with all applicable codes and regulations. Hiring a qualified electrician can help to prevent electrical accidents and injuries and can also help to ensure that your electrical system is reliable and efficient. When hiring an electrician, be sure to check their credentials and references. Ask about their experience with the type of work that you need done. Get a written estimate before work begins. Make sure that the electrician is licensed and insured. Follow these tips to ensure that you hire a qualified electrician who can provide you with safe and reliable electrical services.